So this is the second part of the bonding and structures questions video. I'm just whiz through to where we got to last time, and again we find we've got a reaction between magnesium and fluorine, and again they've given us the structures, or the electronic arrangements at least, of magnesium and fluorine. So what happens when these two react? Well, they produce an ionic compound. We know it's ionic not only because they've told us, but because we've got a metal and we've got a non-metal. And both the metal and the non-metal want to acquire a full outer shell of electrons. So what happens is the magnesium loses 2 electrons. Okay, so it loses that one, it loses that one, and these electrons are picked up by the fluorine. So the fluorine will pick up 1 electron, and so fluorine now has a complete outer shell of electrons. We still have 1 electron to house, and that will go into a second fluorine atom. So there was electrons. There's our electrons. So 2F gain 1 electron each, and so the magnesium now becomes 2 plus because it's lost 2 electrons in fact, and each fluorine becomes 1 minus. And the question asks us for the formula of each of the ions in magnesium fluoride. Well, magnesium has lost 2 electrons, so it'll be Mg2 plus. Each fluoride has gained 1 electron, and the electron is negative, so it'll be F minus. And then if we were asked for the formula of the compound, which we're not, it would be MgF2. We need 2 fluorides for each magnesium. And the final question we look at talks about hydrogen, the smallest molecule, H2. Now, the combustion of hydrogen gives out a lot of heat. What term is used to describe reactions that give out heat? Well, reactions that give out heat are referred to as exothermic. So they give out heat, so they make very good fuels. And we often say that their delta H is negative if it's exothermic. Delta H stands for change in enthalpy, enthalpy being a posh chemist's word for heat energy. So delta H, which is change in heat energy or change in enthalpy, is negative for an exothermic reaction. And I've just got off on a bit of a tangent here, but when hydrogen combusts, it reacts with oxygen. Okay, and it produces water. Now, we need to balance that equation. So we've got 2 hydrogens on the right, 2 hydrogens on the left, but unfortunately we've got 2 oxygens on the left and only 1 on the right. So if we doubled that, we at least sort out our oxygens. This means we've now got 4 hydrogens here on the right. So I'll put a 2 here, 2H2, and that balances it out. Now, in a molecule of hydrogen, if we move on to part B, the atoms are joined by a strong covalent bond. What is a covalent bond? So I'm hoping you remember SPOE, which is enough to at least get you 1 out of 2 on this question. So SPOE means a shared pair of electrons. And that will get you 1 mark, and that pair of electrons are attracted between 2 nuclei. Okay, so here's 1 hydrogen atom, here's the pair of electrons, and here's the other hydrogen atom. And the 2 nuclei there attract that pair of electrons. Now, hydrogen is a simple covalent molecule. It doesn't form a giant structure like diamond or graphite. It's a simple covalent molecule. And therefore, this unit here is a molecule. And here is another molecule. And these are attracted to each other, only ever so slightly, by weak intermolecular forces. Intermolecular being between molecules. And because these forces are so weak, it doesn't take very much energy to pull this molecule away from this molecule, so they're further apart. So let's say this kind of distance. Imagine if that's our hydrogen and his. Well, let's keep this one at the same place. So we've just pulled the two molecules away from each other. Now, we haven't actually broken any bonds. It's still H2 and H2, so we've broken no covalent bonds. But what we have done is we've overcome the weak intermolecular forces. So the answer to this question is, well, let me have a think. It's quite early on a Sunday morning. Why is hydrogen a gas at room temperature? Only a small amount of energy is required. My writing's got even worse. To overcome, I'm going to run out of space as well. Let's see if I move this. Oh, fantastic. The weak intermolecular forces between the H2 molecules. And that's it. So those are a number of past exam questions, and hopefully they've provided a little bit of consolidation for your study of bonding.